Children, in the previous part, we had studied about Dalton's atomic theory, laws of conservation of matter, laws of constant proportion. Now, in this part, we shall study structure of atom, mass of an atom, and chemical symbols of elements. Now, as you can see, that atom is the smallest thing which the matter is made, or you can say atom is the building blocks of all materials. Atom is made up of three types of particles: protons, neutrons and electrons. Now you can see the structure of an helium atom, in which protons are shown, neutrons are shown and the electrons. If you observe, protons and neutrons are located in the nucleus. So, an atom has central nucleus with protons and neutrons in it. Protons are positively charged and neutrons, being neutral, has no charge. Hence, nucleus is positively charged. So, protons and neutrons are collectively called nucleons. Electrons are negatively charged and located around the nucleus, as you can see in the picture that how electrons are moving around the nucleus. An atom has the same number of negatively charged electrons as it has positively charged protons in the nucleus. So therefore, we can say atoms are electrically neutral and it has the same number of protons which is equal to the number of electrons. Now children, you take a piece of chalk. Go on breaking it into smaller and smaller pieces until it reaches to a powder. At least you can see the powders, but if you go on breaking it furthermore or powdering it furthermore, you will reach to a stage where it cannot be seen. It says that single atom cannot be seen, but we can measure it by using or by determining by its radius. So, we can say that we can measure the size of an atom with atomic radius. So, as we have said that single atom cannot be seen, but we can measure the size of an atom with atomic radius. So, what is atomic radius? Atomic radius of a isolated atom or an chemical element, it is a measure of the size of its atoms, usually the mean or distance from the center of the nucleus to the boundary of the surrounding cell of electrons. Or in a simpler way, we can say that the atomic radius is the distance between the nucleus of an atom and its outermost orbit. The units for measuring atomic radius is expressed in nanometers. So, you can say that 1 nanometer is equal to 1 upon 10 raised to 9 meter. So, 1 meter will be equal to 10 raised to 9 nanometer. So, there are atomic radius of different atoms can be easily calculated. For example, hydrogen atom has atomic radius 10 raised to minus 10 meter. Water molecule has 10 raised to minus 9 meter. Hemoglobin molecule has 10 raised to minus 8 meter. Grain of sand has 10 raised to minus 4 meter. Atoms are very tiny as we have seen. Modern instruments like the electron microscope, field ion microscope, scanning tunneling microscope have the capacity to show enlarged images of the atom. The atomic size depends on the number of electron orbits in the atom. The greater the number of orbits, the larger the size. For example, you can see that hydrogen atom has one orbit and lithium atom has two orbits. So which atom is bigger in size? You can say that lithium atom is bigger than an atom of hydrogen. Why? Because lithium has two orbits and hydrogen atom has one orbit. Similarly, you can say that potassium atom which has 4 orbits and sodium atom has 3 orbits. So we can compare and say that potassium atom is bigger than an atom of sodium. Children, as we have seen that atoms are so small, or we can say that an atom is very tiny. They make the entire globe. Our body itself is made up of atoms. Do you think they will have mass? Atoms come together to make up matter, and if matter has mass, atoms must possess mass. But how we calculate the mass of a single atom? Is there any weighing machine or any instrument to measure them? Scientists too struggle with this question. It was not possible for scientists of 19th century to measure atomic mass accurately. Therefore, the concept of relative mass of an atom was put forth. Now, what does it mean? A reference atom was required for expressing the relative mass of an atom. In this case, the hydrogen atom, being the lightest, was initially chosen as the reference atom. The relative mass of a hydrogen atom, which has only one proton in its nucleus, was accepted as 1. Therefore, the magnitude of the relative atomic masses of various atoms became equal to the atomic mass number, that is, the sum of the protons and neutrons. Let us see how to express the relative mass of a nitrogen atom, having accepted the relative atomic mass of hydrogen as 1. The mass of one nitrogen atom is 14 times that of an hydrogen atom. Therefore, the relative mass of a nitrogen atom is 14. This is how the relative atomic masses of various elements were determined. On this scale, the relative atomic masses of many elements came out to be fractional. Therefore, in the course of time, different atoms were chosen as reference atoms. Finally, in 1961, the atom of carbon was selected as the reference atom. It means that the relative mass of a carbon atom was accepted as 12. The relative atomic masses of the relative atomic mass of one hydrogen atom compared to the carbon atom becomes 1. That is the 12 times of 1 upon 12, that is 1. The mass of one proton and of one neutron on the scale of relative atomic masses is approximately 1. Now you can see the chart given below which shows the atomic masses of different elements. Now we shall see chemical symbols of elements. Dalton used certain signs represents elements. For example, for hydrogen he had used one symbol, for copper he had used the symbol. Today we use the symbols determined by IUPAC, that is International Union of Pure and Applied Chemistry. These elements were denoted by symbols. John Berzelius suggested to use first letter of English name of an element written in a capital letter that should be used as a symbol, like H for hydrogen, C for carbon, P for phosphorus, O for oxygen, etc. There were names of many elements started with same letter, like C for carbon, C for calcium, C for chlorine. In this case, two letters were used as symbol. Example, Ca for calcium, He for helium. That is, first letter is written in capital, second letter is written in lowercase. Now, symbols of all elements are not taken from English name. Instead, they are taken from their name in Latin, Greek, or German. Example, Latin name of silver is argentium and its symbol is Ag. Latin name of potassium is kalium and its symbol is K. Latin name of sodium is natrium and its symbol became Na. Latin name of iron is ferrum and its symbol became Fe. You know, in the beginning, the names of elements were derived from the name of place where they were found, or you can say where they originated for the first time. So they were named after the place of origin. For instance, copper was taken from Cyprus. The Roman Empire obtained most of the copper from the island Cyprus, which is where copper name originated. The Latin name of copper is cuprum and its symbol is Cu. Gold, the Latin name of gold is aureum, which originally meant gold. Lithium gets name from Greek word for stone, lithos, because it was discovered in a rock. Carbon comes from Latin word carbon, carbo, meaning coal or charcoal. Neon takes its name from neon, the Greek word for new. Phosphorus literally means light bearer or light bringing, glued as the first compound of the element glued in the dark. A century before it became the name of element 15 in the late 1600, phosphorus was an alternative name for the planet Venus, whose appearance in the sky was once believed to strengthen the light and heat of the sun, etc. Thank you, children.